Okay, here is our last lesson for chapter 13. It's on section 13.6, and it's titled Apply Law of Cosines. And I've also decided to talk about finding the area of a triangle. Instead of using 1/2 times base times height, there's a couple other ways you can find the area of a triangle if you're given some of the sides or two sides and an angle. But first, let's talk about law of cosines. The law of cosines is like the law of sines. It's used to solve a non-right triangle. But more specifically, we'd use it for the SSS or SAS cases. And here are the formulas. So imagine you have a non-right triangle. Here is A, here is B, and here is C. And here is little a, here is little b, and here is little c. If you happen to know all three sides, then if you use this formula here, a squared, which we know, b squared, which we know, plus c squared, which we also know, minus 2bc times cosine A. That would be your unknown. But of course we know b and c, a squared, b squared, c squared, all the lowercase stuff. So you'd have one equation with one unknown. You could solve for angle A. And then use law of sines to get either angle B or angle C. And then once you have that, once you have two angles, then you can find the third angle by just doing 180 minus the sum of the other two angles. So you definitely can use it for SSS. Can also be used for SAS, the sassy situation. A, B, C. So say for example we knew, and actually let me label the sides as well, little a, little b, and little c. So say we know little a and little b, and we know angle c. See how it's a side angle side situation? So if you think about it, we don't know c squared, that's a question mark, but we know a squared, we know b squared, we know 2ab, and we will be able to find the cosine of angle c because we're given angle c. So if you're given two sides and an angle, the angle in between those two sides, you can use law of cosines to solve for the third side. And once you have that, so you solve for little c, and then use, again, law of sines get angle A or angle B. And of course, once you have one of the other angles, to find the third angle, you can use the fact that 180 represents the sum of all the angles in the triangle, so 180 minus the sum of the other two angles will get you the third angle. So these are the way law of cosines can be used, and we'll do that in the two examples that follow. Another thing I want to mention before we start the examples is how to find the area of a triangle. So you can use these formulas for the SAS situation. You can use this formula for the SSS situation. So if you're given side angle side, you know two sides and angle in between them. Notice how this guy right here could be used for that triangle. So 1/2 AB sine angle C would get you the area for the triangle we just discussed. Um, this one, if you know all three sides, so A, B, C, little a, little b, little c, S is what we call the semi-perimeter, because A plus B plus C is a perimeter, but you're doing 1/2 of it. If you plug it into this formula right above, square of S times S minus A times S minus B times S minus C, you can find the area of a triangle that way as well. And this actually has a specific name. It's called Heron's area formula. So instead of your standard A equals 1/2 times base times height, there's two other ways you can find the area of a triangle. And actually we could derive these by using the fact that 1/2 times base times height gets me the area of a triangle, but I'll save that derivation for another time. Maybe we could do that as a problem during our classwork. Alright, so now let's look at the examples. Here you have to solve triangle ABC when you're given little a, little c, and the angle B. So let's draw a triangle, and this is like example on page 889 in the book. Okay, so here's A, B, and C. Here's 11, that's 14, and that's 34 degrees. So clearly we don't know those two angles, nor do we know the side opposite angle B. So use the law of cosines to find little b. So little b is going to equal a squared, or 14 squared, plus c squared, which is going to be 11 squared, minus 2ac times the cosine of 34 degrees. Just work it out. Should be pretty simple, just by using the, I'm sorry, I meant to say b squared. So b squared should equal roughly 61.7, so b would be 7.85. And of course, you just use your calculator to work that out. Once you get that, then we can use the law of sines to work out the rest of this. For example, sine A over little a could equal sine B over little b. So let's see here. Sine A over 11 equals sine 34 degrees over 7.85. Because now we have a pair of side or angle and a side opposite of that angle that we can use. And then we can compare it to another ratio that's similar and then solve for the angle. If you solve for this angle, you might want to pause the video and try it out, but this you guys should have seen or should know how to do. You would get 51.6 degrees for angle A. And then lastly, the third angle, angle C, will be 180 minus A plus B, which would get you 94.4 degrees. Now then you could try doing the check your work. So the program I gave you, trick solve, if we were to punch that in, so we know two sides, one angle. Do you know the angle between the two sides? Yes, I do. The first side's 14, other side's 11, angle's 34. And you can check and you see that we do get all the right answers. So that's very good. And then the area. The area, because it's side angle side, I'm going to do 1/2, in this case times AC times sine angle B. So 1/2 times 11 times 14 times sine 34 degrees. If you were to work that out, 0.5 times 11 times 14 times sine 34, 43.058, which trick solve gave us as well. Okay, let's try one more example and we'll be done for today's video. So in this case we have the side-side-side situation. So ABC, this is example 2 on page 890. That's 12, that's 27, that's 20. So now in this case, you can find any angle you like, but you got to start with law of cosines, because you can't use law of sines since we don't know a pair of side and angle that are opposite of each other. So use law of cosines. So let's see here. Let's say we want to find angle A first. So I say 12 squared would equal 20 squared plus 27 squared minus 2 times 20 times 27 times the cosine of angle A. And angle A's are unknown. So you want to isolate that as much as you can. So if you work things out, you would wind up getting the following. Cosine A should equal, see, 12 squared minus 20 squared minus 27 squared divided by negative 2 times 20 times 27. Yeah, so you should get 0.912. So you solve for angle A, take the inverse cosine of that. So here's cosine of 0.912. Angle A would be 24.217 degrees. Then let's say we want to find angle B. Now you got to use law of sines. So you're going to have to use law of sines for all these problems. That's why law of cosine is always covered after law of sines, because you got to learn that first. Let's say we want to find B now. So sine B over 27 equals sine of 24.217 degrees over 12. And you might want to actually store your angle. So if the store button's right above the on button, so store, and then alpha math, that's A. So we have that stored. Isolate sine B. So you should get 0.923. Take the inverse sine of that. And looks like I made a mistake somewhere because this doesn't come out quite correct. Wonder what I've done wrong. 7.33. Oh, interesting. Very, very interesting. I see what happens here. So the calculator gives us this, right? So what that means is when we solve for C, we would get this. But here's the problem. This implies that side C is along the side. Now, is that true? No, it's not true. So what that means is that we actually ran into the ambiguous case with our law of sines here, because we're dealing with side-side angle if you think about it, when we're doing law of sines. So these are actually impossible. So what you would do is actually realize that when we do the inverse sine of 0.923, you do get 67.33 degrees, or it could equal 180 minus that. Because remember, in the second quadrant, when you're in the second quadrant, sine's still going to be positive. So sine of 112.67 degrees will still give me 0.923. Now this would be more legitimate because little b is actually larger than all the other two sides. So we'd actually would have to go with that one. So I think the moral here is that when you're doing inverse sine, see if you can get another angle in the second quadrant and see if that makes sense. So you're going to have to actually inspect it and see what makes more sense. 112.67 makes more sense because side b is obviously the longest side. So now in this case, C will be 180 minus 112.67 plus 24.217. And so if I work that out, then I think I'll officially be done with the problem. Yep, so you have 43.1 degrees. And then in the area, if I use Haran's formula, the square root of S, now S, remember, is 1/2 the perimeter, which will be 1/2 12 plus 27 plus 20. 12 plus 27 plus 20 divided by 2 equals 29.5. So 29.5 minus 12, 29.5 minus 27, and 29.5 minus 20. Let's work it all out. Square root so you should get 110.729 as our area. Then as a last check, if we do trig solve, so you know 3 sides, no angles, 12, 27, 20, and actually it does give us the right answers. So trig solve is definitely a nice program to have. Obviously you could do this question in about 5 seconds as opposed to spending 5 minutes going through all this work here. But you obviously do have to show the work. Okay, so we're all set for today. This will be our last video before we start chapter 14, which we will begin late next week. Alright, that's it, and I'll see you guys later.